Previously, we did a ARMA forecasting on stock price time series. The ARMA model fits very well to the raw data with only two coefficients. However, one underlying assumption of ARMA model is that the time series is stationary. This is obviously not true for any stock price time series. So in this video, we'll try to improve the time series forecasting with ARIMA model. ARIMA is an acronym that stands for Autoregressive Integrated Moving Average. It is a generalization of the simpler autoregressive moving average ARMA model and adds the notion of integration. However, I feel that this notion of integration is a bit misleading. It is actually a differencing process to mitigate the non-stationary. For those who are interested to know the theory of ARIMA, please refer to some other videos in the YouTube. In this video, we will more focus on the implementation of ARIMA model on the stock price time series. Let's illustrate the ARIMA model with the stock price data. First, we will download the Intel stock price and visualize the adjusted close price time series. Apparently, it is non-stationary. You can readily verify the non-stationary using the ADF test. If the null hypothesis is rejected, the time series is stationary, else it is non-stationary. So we perform the ADF test from the stats model package on the Intel stock price data. The ADF statistic is -1.59 and the p-value is 0.48, which is much larger than 0.01. So we conclude that we cannot reject the null hypothesis. Therefore, the time series is non-stationary. Next, we can also check the normality of the data by plotting the QQ plot. Since the adjusted close price is pretty close to a normal distribution. Next, we will do an autocorrelation analysis on the Intel stock price data. It shows a very strong moving average component and an autoregressive component of one leg. Next, we will try to model the time series using the ARIMA model with an order of 1, 1, 1. We do a fit to the historical time series data and the coefficients are shown below. The AR coefficient is 0.68 and the MA coefficient is -0.68. Next, we do a forecast of the time series using the trained ARIMA model. We overlay the forecast data to the raw data and similar to the ARMA model, the ARIMA model forecast fits very close to the historical data. This concludes the video on ARIMA forecasting. The code can be downloaded below. The video on ARMA can be referenced below. Feel free to comment below and subscribe to our channel. Thank you.